Hello and welcome to today's webinar, Software Eats Traditional Storage. My name is David Davis and I'll be the moderator for today's event. Thanks so much for taking time out of your busy schedule to join us today to talk about this. It's really an exciting topic and we've got a lot to cover. Just a few things before we get started. The first one is if you have questions during the event, please use the GoToWebinar control panel there to ask your questions, and we'll be answering those questions in a nice Q&A session at the end of the event. So we hope to spend a lot of time answering all of your questions. We also have a $300 Amazon gift card to give away for one lucky attendee today, and we'll be announcing that winner at the end of the event. Also, in your GoToWebinar control panel, we have a handout section there where you can download the resources from today's event. We have the slides from today in PDF format, as well as a book that I actually wrote covering hyperconvergence fundamentals. It's a very nice ebook that you can download and check out to learn more about hyperconvergence. So with that, let's go ahead and get started by telling you a little bit about the speakers today. Again, my name is David M. Davis. I'm a partner at Actual Tech Media. I'm a 7-time VMware V expert and an author of numerous video training courses at Pluralsight.com, mostly around VMware vSphere, virtualization, and cloud computing. I'm a blogger and speaker, and I'm proud to be joined today by Kiran Murthy, who's the Director of Product Management at Maxta. Thanks so much, Maxta, and thanks, Kiran, for joining us today.
Thank you. Welcome, everyone.
And before we jump into today's topic, I have a couple quick poll questions for the audience just to help us learn a little bit more about you and your needs, on this event and on future events. So if you don't mind answering a couple quick questions, tell us what's the size of your company, roughly the number of employees that you have in your company. It's good to know that, to know, do we have small companies on, large companies on, medium size? And then, it's interesting to find out what your needs are in relation to software-defined storage, hyperconvergence, and, what technologies are you considering, now and in the future? So let me go ahead and close those poll results and share those. And as you can see, we've got a good range of companies on, a lot of 1,500 plus employee companies, large companies today, but also some, companies on the small and medium size. And then one more other easy question, and that is, how many virtualization hosts do you manage in your data center today? It could be vSphere, could be another hypervisor, but roughly what's the number of hosts that you have in the data center that are running a hypervisor? All right, 60 or 70% of you out there voted. I appreciate that. Let me go ahead and close the results and share those. And as you can see, again, just like the wide range of companies, we have a wide range of the number of hosts running a virtualization platform in the data center. So that's all the poll questions for now. And let's go ahead and talk about today's topics. So what we'll be covering first is why the traditional storage design is outdated, in my opinion. What is it about it that is just not going to work for the future? We'll cover how software-defined storage and the software-defined data center can help to make the life of data center admins easier and help to prepare the data center for the future. We'll cover how today's software-defined storage solutions are ready for production, what makes a solution ready, and why today's solutions have matured to the point that they are, or how they've matured to the point that they are ready for production. And then finally, how Maxta's solutions can help. So briefly, I want to talk a little bit about an article that came out in 2011. So 5 years ago, Mark Andreessen published a blog post called "Why Software is Eating the World," and it kind of predicted the future from then and until now. And as we can see, if you look around, the enterprise technology solution, marketplace at any conference, at any expo, you see more and more, software solutions, and that's because software is getting smarter, hardware is getting more commodity based, and it's just getting more and more powerful. So there's so much more, that we can do with it. But he really kind of set the stage and predicted the future, with this article back in 2011. And then I also found it interesting that Andreessen Horowitz, who's the venture capitalist firm, the co-founder is Mark Andreessen, um, published this, blog post later in the Wall Street Journal and talked about how his firm had invested, in Maxta because Maxta is a software-defined storage hyperconverged solution, and it's just one of the examples of how, software is eating the world. This is a graph from Wikibon. Thanks to our friends over at Wikibon Research. They published this where they predict, storage revenue by capacity versus, latency, flash, and hard drive storage solutions from 2012 to 2026. And as you can see, their predictions are that really traditional storage, SAN capacity, the number of enterprises purchasing that and the dollar amount spent, over time, as you can see, is just going to go down and down and down, and new technologies such as flash storage and software-defined storage solutions are going to increase in revenue over time. So it's not just Andreessen Horowitz, that's predicting this. It's research firms, and I think everyone out there knows it as well. But why traditional storage is outdated and why companies are moving, to more software-defined solutions. First off, if we step back, you see the 5 megabyte, 2,000 pound hard drive there on a small forklift being loaded into a Pan Am plane many years ago. That was dedicated storage, from the past. But in many data centers, we still have, a SAN array that's at least that big. Obviously, it holds a lot more capacity and it's a lot higher performance. But, we have this big, massive, dedicated box, that many companies use just for dedicated, file storage. And it's expensive. We all know it. It's usually the most, single expensive piece of hardware in the entire data center. And companies have to justify, well, we put everything in it. Yeah, that's why we have to spend so much. But it doesn't have to be, so expensive, in my opinion. It also doesn't have to be so complex. I mean, a lot of companies have dedicated SAN administration teams. They have dedicated storage admins that go and get certifications and go to classes, just to run this single expensive piece of complex hardware. And at many companies, it was only necessary to put in the SAN because the servers just didn't have the performance, or they didn't have the capacity or the feature set that was needed, and so that's why they had to look for this very expensive piece of complex hardware just to store their data. But if looking back, if the servers had been as fast back then as they are today, and if they had the capacity and the performance, then most likely we would have put our storage, our data on local storage, assuming we could get the advanced feature set that we needed. High availability, high performance I/O, things like that you look for in a SAN. So, traditional storage, it typically has a static feature set. You purchase a SAN, it has a set number of features, and that's all it's going to do. In some cases, there are like firmware upgrades or software upgrades that might provide something additional, but you're also paying usually very high maintenance to get additional features. Usually, there's also dedicated license keys to get advanced features, so you might have to buy replication and pay for it on each of your storage arrays. You're also very locked in to a particular vendor. Once you purchase that dedicated SAN, it's going to be a long time, maybe 5 to 7 years before you replace it and get a new SAN, because it's so expensive, so complex. You have such a vendor lock-in of such a investment in it. You're probably not going to move off of it, and it's also very difficult and challenging in some cases to move off of. It's also outdated because this tremendous complexity. In my opinion, it's unnecessary. Fiber channel, iSCSI, LUNs, RAID striping, all these things. In many cases, they just create more problems, in the data center when it comes to troubleshooting and when it comes to, capacity planning, because you have everything broken up into, different LUNs. And like I mentioned, the SAN requires dedicated staff, training and certification. And it's also very expensive to scale. When you need to add new storage to the SAN, you might have to add a whole, disk drawer full of disk. Might have to add many more spindles, and that's because you're using that storage that you have, very inefficiently. It's not just one pool of storage. It's carved up, into very specific LUNs for dedicated, applications or groups of virtual machines. And so now let's move on and talk a little bit about the software-defined data center, or the SDDC. And many people associate this, perhaps with VMware, because VMware has pushed this term, so much. But it's not a VMware only term. The software-defined data center is an industry accepted general concept, for running your data center as much as possible, in software. So the software-defined data center is, software-defined compute, which is your virtualization layer, your hypervisors, such as VMware vSphere. You have software-defined storage, which is a hyperconvergent solution. Essentially, it doesn't have to be, but software-defined storage is essentially running your storage within the compute layer. And more and more that's being, hyperconvergence is the merger of these two into one. Software-defined compute and software-defined storage into a single solution with a single management point. And Kieran will talk more about that. And then the software-defined data center is also, software-defined networking. So running essentially the three, main pillars in the data center and doing it in software. And then it's managed by an overarching, single point of, management, a cloud management tool, along with some automation. So this is kind of where most companies would like to move to. But they also need to be aware of that it doesn't have to be, an all VMware solution. There's multiple solutions to each of these different, types of software-defined offerings. So how can the software-defined data center help you? And, simplified management in the data center, easily scaled, a dynamic feature set, lower cost to scale, uses commodity hardware, and vendor flexibility. So by doing things in software, you can dynamically move out, scale out, for example, your storage needs to different types of commodity hardware. So it's a lower cost. You don't have dedicated storage from a SAN or NAS vendor. You have great flexibility in these different silos. Which silo you choose, you could use a different hypervisor for the compute layer and different vendor for software-defined networking. But ideally, the management is all brought together into one place to make management, monitoring, troubleshooting, capacity planning, all those things so much easier than having different silos, a storage management solution and a virtualization management solution and the network management group and whatever tool they use. So back to this title, the title of our webinar today, why is it the software is eating the world? Well, software is going to be lower cost. By doing things in software instead of having dedicated hardware to perform a certain task, whether it's storing your data or running your network infrastructure, by doing things in software, it's a natural that you're going to save, hopefully, some money. It's much more efficient, as we know. We don't have to buy dedicated hardware to do certain specific tasks. It's going to be higher performance because today's commodity hardware is so much faster and higher performance than ever before. You're also going to get more advanced features, and an ease of adding additional functionality. I mean, if you think of your iPhone or Android device, when they release a new operating system on it, you download it, you update it, you get advanced functionality. You don't have to go out and buy typically a whole new hardware device just to get that. And that's kind of the same concept here with software. When new features are added, that functionality is just included in the latest upgrade. You don't have to buy a dedicated license key just to use it. Software makes the data center more scalable, more efficient, and overall so much easier to manage. So how is this possible? I mean, you have faster and faster CPUs and memory advancements. Memory is more and more dense. Today's servers, can handle the needs of, software-defined storage and software-defined networking. They can handle those needs that they couldn't handle in the past. The capacity, just wasn't there. We also have faster and lower cost flash storage. So the storage capacities of flash is increasing pretty rapidly, and as we know with flash, the latency is very minimal, compared to traditional storage. So by having all of these components, brought together and paired with, better and better, faster, more efficient, better designed software that's usually using, virtualization, we can really do some amazing things today. And I think not every, admin out there is aware of some of the latest innovations out there. So why is it that software-defined solutions and software-defined storage is ready for the data center, in my opinion? It's because virtualization, as most everyone out there knows, has matured. We're running tier 1 applications on our hypervisors today. We feel comfortable, with our virtualization platforms, and really we're ready for the next step. I think most companies out there are ready for that next step. They might not have gotten to 100% virtualization, but they're ready to start looking for greater efficiencies, in their virtual infrastructure. They realize that virtualization has given them tremendous efficiency already, but I think everyone's starting to realize there's more. There's more that can be done to make the virtual infrastructure more efficient. I mean, if you think of the time that it takes to provision a new application in most companies, if you have a dedicated, SAN administration team, a network administration team, there's still a lot of delay and a lot of inefficiency because the SAN admin has to provision perhaps a new LUN, do some RAID striping, talk about the capacities and the IOP requirements. Maybe he has to order some new disk because he's out of space in the existing SAN, and then the network admin has to provision some VLANs or whatever it might be. There's a lot of inefficiency still happening, in the IT infrastructure groups. Software-defined storage and software-defined networking are built on top of virtualization. So these solutions are virtualized, and they're using our mature, reliable, virtual infrastructure that we've really started to trust and rely on. Software-defined storage has been proven. There's reference architectures out there for software-defined storage solutions, big companies that have done it, case studies. You see, massive internet companies that are all using software-defined storage, in some way. So it's not a cutting edge, concept anymore. And then, there's this term hyperconvergence, and I think a lot of admins out there are still confused on, exactly where does this fit in with the whole, virtualization, software-defined storage, software-defined data center, picture. How does hyperconvergence, fit into that? Hyperconvergence is really utilizing software-defined storage and distributing that storage across your hosts on top of a hypervisor, typically, and then integrating the management of the virtualization layer and the software-defined storage layer into one point of control. So that's my elevator pitch, definition of what hyperconvergence is. But I'm sure that Kieran will have more, information to share on his take on that. The business benefits of hyperconvergence: by bringing the compute and the software-defined storage together, you're streamlining the infrastructure deployment process. So when you go to deploy a new virtual machine, think about if you could just define the I/O requirements of that virtual machine and the availability requirements and the caching, perhaps level of that virtual machine, storage, when you're provisioning that VM, and it just happens behind the scenes, and it's just there, and it's like one giant pool of storage instead of working with a storage area network and everything that goes along with that. You get simplified IT operations, so provisioning applications faster, greater efficiency, better use of the storage, no more complex storage environment to manage. So you could essentially get rid of the SAN or the NAS and everything that goes along with that, the maintenance contracts, the certification, and you could get this granular Lego-like scalability where when you need to add more capacity, instead of looking at the SAN and well, we need to add these drawers and all these disks and so forth. With hyperconvergence, you just add a new physical server, and along with that comes storage as well as compute, and you're scaling your storage and your compute together. Many hyperconvergent solutions also give you the benefit of scaling those separately. So you might be able to just add storage only to an existing compute node. So you scale by adding more Lego-like blocks, and the software, the smart software, this hyperconvergence solution really glues it all together. More benefits of hyperconvergence, significant performance improvements really over the typical legacy infrastructure, and that's because most hyperconvergence solutions use some type of caching. They use flash storage, and from that you can get tremendous performance improvements compared to what we are traditionally seeing in the SAN. You also, you don't have to purchase a dedicated flash storage array though. With hyperconvergence, you might just have one flash disk in each of your physical hosts, and the software-defined storage solution uses that for caching to accelerate all of your applications and all of your virtual machines. You can also use commodity hardware. So use the hardware that you have already, without purchasing new hardware in the data center. And then finally, a simplified administrative paradigm. So a single point of management, control, and monitoring for not only your software-defined compute, but also your software-defined storage. And there's the potential, of course, to redistribute, staffing. If you could really get rid of the SAN or the NAS and you have dedicated admins for that complex infrastructure, there's always more to do in IT, right? There's always more applications and technology to implement. So perhaps they can become hyperconvergence administrators and administer the software-defined storage instead. But the cool thing here is that with hyperconvergence and the software-defined data center paradigm, really, I believe it allows us to elevate all of ourselves to become, kind of the infrastructure admin who can administer all the infrastructure, because with these software-defined constructs, the infrastructure becomes less complex to administer. So we can really start to become, this infrastructure admin that we'd really like to get to. And elevate ourselves, in the organization. And the great thing is, when you add more storage in the data center, you don't have to add more administrators and add more, SAN drawers or disk or whatever it might be. There are a few considerations for hyperconvergence that you need to be aware of. Take into account the hypervisor, options that you'll have available to you with the hyperconvergence solutions. You also want to maintain your hardware choice. So ideally, you don't want to be locked into one particular model or brand or vendor of hardware, if possible, in a hyperconvergent solution, because then you're kind of back to the SAN paradigm where you're kind of locked into a particular solution. You want to maintain flexibility as much as possible, and you also want to ease your management burden. So you don't want to have one management console for the software-defined storage solution and another one for your virtual infrastructure. You want to bring it all together, as well as add additional functionality So what else can the software-defined storage solution do above what the SAN was already doing for us? What advanced features are now available in this smart software-defined solution? And then hopefully achieve some sort of cost savings or reduce costs in the future in the data center by using smart software and commodity-based hardware. So if you'd like to read more about this, you can download in the handout section in the GoToWebinar control panel there the book I wrote on hyperconvergence fundamentals, available in PDF. And so to talk to us about software-defined storage and hyperconvergence, I invited on Kiran from Maxta. And Kiran, are you there?
Yeah, I'm here.
Excellent. Well, take it away. Tell us about how Maxta's solution is unique and how it can help data centers and admins out there at all sizes of companies.
Sure. Thank you, David. So we will go through some of the, or reiterate some of the things that David talked about around what is software-defined storage, what is hyperconvergence. There are a lot of buzzwords around in the industry, just to level set what they really mean. And then we will go into some specific details about the issues that you may encounter when you are dealing with software-defined storage, how Maxta is addressing all these things. So let me just give a quick overview of what do we mean by software-defined data center. So at the heart of it, it primarily boils down to things are virtualized and all the layers of services that are provided within the data center are delivered in software. Essentially, all your main services like compute, your networking, and your storage are delivered in software, and they're necessarily run on standard x86 servers. There is no specialized hardware. There is no specialized ASICs and things like that, or FPGAs built into it. Everything is possible through software, and you run your entire data center with software being the core of it. Next slide, David. So now, if that is the case, what does software-defined storage really mean? As David pointed out, the key aspect of it, at the heart of it, it's software implementation. That's the fundamental portion of it. And around it is we should be leveraging standard commodity components. No need for specific hardware architecture. The second aspect is make it hypervisor agnostic, meaning you are not tied to a particular hypervisor. Today, 90% of the data centers run VMware vSphere as their primary hypervisor. Down the road, they may want to run a mixed environment. So customers have the flexibility of running VMware vSphere and other hypervisors when required. The third aspect is there should not be any loss of enterprise class services from the storage perspective that customers are used to. Simple things like efficient snapshots, efficient clones, replication, data integrity, all the features that customers are used to from a storage perspective should all be available even when they move to a software-only implementation. And the last point is scale. How can I scale my existing environment? Can I scale compute resources only if I require? Can I scale storage resources only if I require? Can I start small? Can I add just storage resources to my existing environment? So all the aspects around make it really simple for customers to be able to scale their environment. Next slide, David. So if that is the case, then what is hyperconvergence? So when we talk about hyperconvergence, as David pointed out, the idea is in addition to just being software implementation, which is a prerequisite, you have to be able to simplify the manageability of it. Provide customers the ability to manage a virtual machine or an application that's running in a virtual machine. Give customers the ability to be able to define policies on these virtual machines or applications so that they get the right level of performance and characteristics that are relevant to the application, not to the point that one size fits all model. Customers should be able to tweak and tune based on what their application needs are. The third aspect is it's software. So the licenses that they buy should be able to transfer across releases and across newer hardware that they buy. Traditionally, customers, when they buy a standard storage platform, they pay for hardware as well as software. When they upgrade, they again pay for software and hardware. The idea of software-defined storage and hyperconvergence in particular is it should be transferable. The licenses, once you buy, and if you, after 3 years, if you upgrade to a different server or a next generation server platform, you should be able to leverage your software licenses. You don't have to repurchase them. And the last lines up with software-defined storage, which is the ability to scale. You would scale your compute resources when required. You would scale your storage resources when required. There is no one-to-one relationship between them. You could scale them independently. And David pointed out another important aspect. You don't need to add resources, or in particular human resources, when you scale your storage, since it's much more simpler to manage. The same person or people or a group can manage more capacity in their data center. Next slide, David. So now, if all these things are true, now let's talk a little bit about the weaknesses in your traditional storage platform and what are the weaknesses in software implementation. So if you look at the traditional hardware-centric storage, if I may say, there are certain benefits to it too. Why would customers or even vendors do that or started off with that model? First and the foremost is they control their entire infrastructure. They control the bill of materials. It gets qualified. They ensure the interoperability between all the different components that are running within the entire stack, whether it comes to the storage controller, the drives, the firmware on each one of them, firmware on the backplane. Everything is controlled, which has the benefits of seamless interoperability, but it comes with certain drawbacks too. That would lead to vendor lock-in. Again, traditionally, we have seen that customers have to pay for software when they do a hardware refresh. It completely eliminates the flexibility. You cannot add the resources from other vendors. So for example, you cannot just increase your disk capacity. You cannot just go buy some additional drives and then add it. You need to worry about does it work with the adapter that I have? Does it work with the server vendor that I have? So a lot of these interoperability would kick in, which undermines the flexibility what customers get, and that leads to an increased cost. Customers have to pay a lot of money upfront and also at the time of refreshing their hardware. Next slide, David. So if that is true, and what we are all saying is 100% true, then are there any issues with software-centric model? What are the gotchas that I should be aware of? And we all know when we talk about software-centric approach, and we say, hey, you can run on any server platform, any hypervisor, they come with certain challenges. As we see, the bill of materials are very loosely controlled. Customers can start working with, I'll pick an example, HP servers, and 2 years down the road, they may want to add a Dell server because it provided some additional capabilities that didn't exist in their previous generation. So there are a lot of things that they can now look at when it comes to software, which makes it very loosely controlled. There will be interoperability limitations when it comes to that, because we need to look into how do we address the firmware incompatibility issues between the HBAs and the drives. How do we control the firmware issues between the backplane and the HBA driver? How do we make sure the BIOS is at the right version that is required? So there are a lot of interoperability challenges which prompted customers and vendors to move to a hardware-centric approach, which has its own drawbacks. And the last one, although not technology-wise, from a business-wise, when it comes to software-centric and when it comes to hyperconvergence, where does the budget lie? Is it the storage? Is it the server? It's nice to have everything in one, but who controls it? When you need additional compute, is it the server budget that lines up with it, or is it the storage? So there are a lot of these technical as well as non-technical challenges when it comes to software-centric approach. Next slide, please. So how do we address them? First, the way Maxtra is looking at this is with Maxtra software, and in addition to it, Maxtra is developing and developed this interoperability certification software. This is a piece of software that is installed on all the servers, virtualized servers, where Maxtra software would be running. We would go validate every component. We would go validate the drives, the firmware, the BIOS versions, and make sure that everything matches to what is the latest and the greatest that's supported. So it's not about just building a static hardware compatibility list. This is more of a dynamic approach. What David talked about early on, things are more dynamic in nature. It's not a static implementation. So when things change, you go rerun this, it will validate whether it meets the requirements. When you're adding new node to your infrastructure, you can run this piece of software. It will tell you if it's in compliance. How does it relate to your older servers and storage that's already there, which are part of the cluster? So it gives you a very good view whether it's a go or a no-go. And the second aspect is about partnership. We have a very strong partnership with Intel and as well as Broadcom. The two key components that is required for your storage to work correctly. Intel from a systems point of view, CPU, memory, system board, and so on. And Broadcom from the controller and as well as the interoperability with the drives from a drives perspective. So we have built a very strong relationship from both these vendors, and both Maxtra software and the components are initially tested, validated, then it gets released in the respective organizations to make sure what customers get is a truly interoperable piece of software and hardware that works together. And we'll get into a little more details about it. So for people who are new to Maxtra, the next couple of slides, I want to just give a quick view of who we are and what our key value and how we differentiate with other hyper-converged vendors. So at a quick overview, Maxtra is funded by Tier 1 VCs, Intel, as well as Andreessen Horowitz that David mentioned before, and also from Tenaya Capital. So the key value that Maxtra brings in the hyper-converged environment is flexibility, the ability to run on any standard servers, whether it's HP, Dell, Supermicro, Quanta, Lenovo, Cisco, any of the standard x86 servers. Not only from a server's point of view, also from a hypervisor point of view. Ability to run on VMware vSphere, ability to run on KVM, and also the flexibility of scaling up, scaling out, everything to do with being flexible in the environment. The second one is the ease of use. Make it really simple. Provide them the ability to manage a virtual machine, not LUNs and volumes and file systems and so on. Make it really simple. Provide the scale that what customers are looking for, and the Lego-like scalability, which is what you scale what you require and when you require, and being very cost effective in terms of both initial deployment as well as being able to scale. And just a quick view of the accolades that we have got from Gartner and CRN and so on. Maxtra goes to market in two form factors. It's the same piece of software, but it's just two form factors. One is just a software that customers can purchase, and the second is what we call a Max Deploy. This is more of a custom, I should say, built to order kind of an appliance. It's not rigid, but it's sort of flexible, and it comes in a prepackaged and appliance sort of form factor, wherein customers can say, I want it on Cisco hardware, I want it with X amount of capacity, so much of CPU resources, memory, and this is the cores that I want, a 10 gig, 1 gig, depending upon what the requirements are. It would be a built-to-order appliance that what customers would get, and this would be delivered by their partners. Next slide, David. So what's the key differentiating factors when it comes to hyper-converged and software-defined storage in the industry? Next slide. First is Maxtra's key value is maximizing choice. providing, as we talked about, the ability to run on any standard servers what customers, whether they have in their data center or in future when they are procuring new hardware. This gives them the ability to even negotiate with their server platform vendors. If they are negotiating between HP and Dell, they get this option because now they have the ability to seamlessly run on these different platforms. So the other, as I said, ability to run on any standard servers. Next is software agility. Provide the ability to be able to run and also even transfer the licenses on onto different servers, whether during initial purchase or at the time of upgrade. Now they can just transfer the licenses to a new server platform that they purchase. Most vendors force you to buy your software when you pre-purchase or upgrade your hardware. With Maxter, you can transfer your licenses. Today, you may start off with, as we discussed, a Dell server platform, and in the due process, it doesn't even have to be a forklift upgrade. You may add one node at a time as part of your refresh cycle, and your licenses gets transferred over. So it's a brand new sort of implementation model, this hyperconverged space, which from a business point of view is a differentiating factor. And application defined. As we have seen in a traditional storage model, customers have, at least, although it's complicated, they have the ability to tweak certain parameters to suit their applications. For example, they can set certain block sizes on some of the storage arrays to meet what their application needs are. They can set different rate levels, maybe rate 10 for certain applications and rate 50 for certain different applications. But when customers moved to the software-defined or hyper-converged models early on, it was sort of, hey, here is a shared pool of storage. You get what is a one common, one-size-fits-all model, which cannot be changed. So it effectively took away the flexibility what customers had. Maxter's model is more of providing them the same level of flexibility and much more simpler in the sense that you can set these at a virtual machine level. You don't need to worry about different LUNs or volumes and so on. You can very easily think of it to say, look, this is my Exchange virtual machine. Or rather I should say, this virtual machine is running Exchange, and I would like it to be 32K to be my page size for my Exchange deployment. You can go set it at 32K. Or if you're running a SQL database and you want it to be 8K or 64K, you can go set them to be that for that particular virtual machine. If it's just standard web services, VDI, you can set it to 4K. So you get the ability to define what you really need. And this expands to be also to setting to your replication factor. Maybe you have your database that you want it to be three-way replicated. You want your Exchange to be two-way replicated. Maybe your VDI, you don't want it. You could just live with two-way replication. So you have the ability to not only go at one of the aspects of paging, but also to the aspects of multiple replication factors that you can set. You can enable, disable compression when required and not required. So there are a lot of these aspects that you can go tweak depending upon your application. Again, all these without losing enterprise class capabilities. Right? So just diving a little more into the architecture of Maxter, as you can see, this is modeled on industry standard servers. Each of these boxes, they represent standard x86 servers. Maxter would install a piece of software on each one of those boxes, and each of these boxes have both a spinning disk as well as SSDs in each one of those boxes. And the Maxter software, along, of course, the hypervisor is also installed on them. Now the Maxter software will integrate all these storage resources together, create a shared pool of storage, and present it to the hypervisor. So what the hypervisor sees is a pool of storage. For example, if let's take a simple one with, say, 10 terabytes in each server raw capacity, and you have 3 servers. We would aggregate all these capacity together, create a 30 terabyte aggregated pool, and hypervisor sees a 30 terabyte pool of storage. Now, all these application virtual machines can consume. For all interoperable or intercommunication between the Maxtra nodes, it's all over standard Ethernet, preferably 10 gig, but it could be 1 gig depending upon the I/O requirement and so on. So they all talk together, create a shared pool of storage that applications now can go access the storage. Very similar in the concept to the CPU and memory. It's like you have a VMware cluster, you have let's say dual socket, 8 cores per server, 16 cores, 3 servers, 48 cores. Now you can slice and dice depending upon what your application needs are. Exactly the same concept from a storage point of view. And Maxter doesn't compromise on any of the enterprise class features. You get very efficient snapshots, very efficient clones, capacity optimization, very strong data integrity with strong checksums, completely integrated into the high availability model of VMware vSphere. And as David pointed out, we leverage SSDs very efficiently for read caching, for write caching, even for metadata, so that we can access, read, and write metadata onto the SSD. Any distributed environment is heavy on metadata. There would be a lot of metadata operations that we have to manage. So it's all on SSDs, giving them the performance that is required. So we leverage SSDs or flash very efficiently to deliver the performance what customers need. And also provide dynamic auto tiering. The historical approach to tiering is, let me go run a piece of software, look at the historical data, and then move the data depending upon it. That's traditional tiering. But in the newer model, it's very dynamic. You read a piece of data. If it's in cache, wonderful. It's delivered to the applications from cache. If it's not, you go fetch it from your spinning disks or your HDDs, and now you provide it back to the application, and at the same time, that piece of data is cached. You don't have to go run any historical analysis to find out should it be in a different tier. So it's very dynamic, and it resides in this tier as long as it's needed, and then when the usage goes down, it's moved back to a colder tier. So it's very dynamic in its approach. The ability to do data locality, when you have certain VMs read and write data, Maxter makes sure that your data is very closely located to where your compute resources are. So if the VM moves over, now eventually the data will also move to where your compute resources are running. We all know the best is when the compute and the storage resources are aligned and they're on the same server and they don't have to go across the wire. So Maxter delivers that. And the last, as we talked about, aligning with applications, giving them the ability to set characteristics and properties based on what the application needs are. Maxter currently is architected to support VMware and KVM and OpenStack, and there are other hypervisors on our roadmap that's being planned to deliver in the upcoming releases. Today, we support VMware vSphere hypervisor and KVM hypervisor. And as David pointed out, from a manageability point of view, it's a single UI, providing the ability to manage both compute and storage. We are very tightly integrated into VMware vSphere, and in the KVM environment, especially when customers using OpenStack into the OpenStack environment, they get a single pane of glass for manageability. Next slide. So we talked about interoperability. What does this mean? The certification software which Maxter has developed, what does it do? What does it mean? What does it give, or what's the benefit to the customer? So as I said, this is a Maxter developed piece of software. It runs on any standard servers, but in a virtual environment. and we test the interoperability, meaning we go validate the firmware, we validate the drivers, we validate the BIOS information, the firmware of the backplane, and so on. It's not just about validating the configuration, right? It's something more to it. We also run stress tests as part of this interoperability certification software. We just don't just match these values together. It runs stress tests on the system. It stresses every drive. It stresses the SSDs, making sure that we don't end up with some issues a week after they move into production. It pretty much stresses the entire infrastructure, every components of the infrastructure, and then says, yes, this is good to go. Now, yes, this can be used in production if some things don't work, if there is a mismatch, if we encounter that there is a mismatch in the firmware versions or so, we tell the customer, look, this has to be upgraded or this has to be fixed before you deploy into production. It provides customers a very, very effective way to say, does my software or does my hardware meet the requirements to run the software-defined or hyper-converged product in production? It's not just saying, hey, let me go look at this HCL and say, oh yeah, everything matches as per they have said. It's good. This is more dynamic. It validates on-site. It gives them a very clear view of what to fix and how to fix it. Next slide, David. The next aspect we talked about the Maxtra piece of software, what it does. We talked about the certification software. The next is about the partnership. What are we doing together from Intel and Broadcom, of course, Avago, LSI, all them together? What are we doing? What's the partnership? So as we all know, whether we initially test all these or not, at some point we may end up with some issues. So having the relationship and the partnership is trivial, and it's a key to success, right? It's actually, in my mind, it's a recipe to be successful. As we have announced in the past, we work very closely with Intel and Broadcom and so on. Maxtra supported Intel Xeon V3 processors on even the NVMe technology at day zero. This was in 2014 when the V3 processor was released. We announced it together with Intel at their IDF conference. Similarly, not just from a hardware point of view, it's even from a virtualization software point of view. We supported vSphere 6 at day zero. The relationship and working with all these industry leaders really provides the ability for the end customers to have the newer technology being able to be deployed at day zero. And Maxtra is working with Broadcom to support their next generation HBA that's in the labs today. So this gives customers the ability to have a fully integrated, tested piece of software that they're all working together, and which is validated by the piece of software and the relationship that we have built together as a team to provide the most efficient support at the end to the end customers. So in summary, what does Maxtra provide to customers? First and foremost, it provides the choice of what customers are looking for in a software-defined model, the ability to run on standard x86 servers, ability to use multiple hypervisors, so on. It gives them the choice. It gives them the flexibility, the ability to, again, use different servers, transfer software licenses, and also provide the ability to set properties at an application level, maximize choice, maximize flexibility, and at the end also delivering cost efficiency to end customers. All these with no compromises to the data availability, the data reliability, and also data protection. And the last but not the least is the partnership and the time to market of the next generation technology from both hardware as well as software from the overall ecosystem. So That's what Maxter delivers to end customers.
Excellent.
With that, I'll hand it over to David.
Thanks so much, Kieran. Excellent presentation. Before we jump into our Q&A and announce our prize winner, just one final question here for the audience. And that is just to find out about your time frame, your interest, your plan for implementing software-defined storage that we talked about here in this webinar today. So I'll leave that up while I randomly select a winner for this Amazon $300 gift card. And that winner is going to be Mike Yoakum. Congratulations, Mike. We'll contact you via email to send out that gift card. Thanks for attending. So let me close those results. And we announced the prize winner, and now it's time for our Q&A session. We have just a few minutes left for Q&A, so make sure you post your question out there. And let me bring up some information here for how to find out more about Maxta's software-defined storage solution. You can contact them, multiple ways there, and also send an email to sales@maxta.com or visit their website. So now let's jump into our Q&A session. Kieran, are you ready for some questions?
Sure.
All right. So I want to make sure everyone understands, because there's a question out here about it. Is Maxta a software-only solution?
Yes, Maxta is a software-only solution. Maxta delivers software.
Excellent. And so if someone wanted to get started with Maxta or test it out, what's the easiest way for them to do it?
The best way is to just contact sales@maxta.com. The process generally we go through is once a customer contacts sales@maxta.com, we will provide them the link to download the software. The customers can download the software. We'll give them the trial license. They can go do a POC in their environment, and based on that, they can go ahead and purchase the product. Or we have actually made it really simple too. We have hosted different POC setups. We give full access to these servers to end customers to do really a POC. They can even install ESX if they would like to, or they can have Maxta install ESX. They can have the experience of installing Maxta. They can have the experience of running it. We give them full control, make it really simple for them to go do a POC. So there are multiple ways customers can engage with Maxta and also do a proof of concept.
Okay, excellent, excellent. And how is Maxta sold? Like per CPU or socket or amount of storage? How's it packaged?
Sure. Maxta's licensing model is based on the number of cores and the capacity that's managed by Maxta. For example, the customer may have 24 1 terabyte drives in the system, and they may have 4 systems to start with. That's 96 drives, but they may initially start off with only half of them. And the licensing is based on the amount of license that's under Maxta's control, both from a capacity and from a course point of view.
Okay. And let's see, there's a question out here about, networking requirements. Is 10 gig Ethernet required between the hosts?
It is not required. 1 gig, we have customers who are running both on 1 gig as well as 10 gig. Some of the branch offices, customers, they all are running on 1 gig network. Predominantly, we see in a data center, it's been a 10 gig network for all the Maxta internode communication. We have customers wherein they provide a VLAN. It's a shared 10 gig between a couple of other management and as well as Maxta, but they provide a VLAN for the traffic between the Maxta, for the storage portion of it between the Maxta nodes.
Okay, good. Another question here just came in. It says, how do you scale beyond the capacity of a single node for the same data set?
So to scale, there are multiple ways Maxta allows customers to scale. let's just talk about the storage. From a storage perspective, there are multiple ways. One is obviously just add a new node with additional storage. That's one way. The second approach is, especially these days, the servers are getting pretty dense. So with 24 drives, you may initially start off with, as I mentioned, half of it populated. Now you can just add a new drive into that system. We automatically pull that in. The third approach is you could replace a lower capacity drive with a higher capacity drive. So you start off with 1 terabyte drives. Let's assume that they're all 3.5-inch form factor, and 6 months down the road, you can go replace this 1 terabyte drive with a 2 terabyte drive. It doubles your capacity. So customers have multiple ways in which they can scale storage.
Okay, great, great. One of the questions is about, what do you say to a storage admin who, in terms of feature set, they're used to their traditional SAN, they're weary about, or leery about software-defined storage. They're concerned about, they have all these features that they're used to using. What does Maxta's software-defined storage solution offer in the way of, features that to kind of give them, parity to make them feel better?
Sure. So one of the key aspects that when Maxta started as a company is we wanted to make sure that there is no compromise on some of the key enterprise class features what customers are used to in their traditional storage platform. So if we really look at it from, just to give a few examples from the ground up, one of the key aspects what customers really, when they talk about enterprise class features, is data resiliency and data availability. How can I be sure that what I write is what, when I read, is what I get back? How do I avoid bit rots? How do I avoid bit flips? How do I make, especially when we are talking standard, industry standard servers, all these things magnifies, but how do I know all these things are taken care of? And the second one is availability. If drive fails, node fails, and so on, how can I make sure that my data is available? So when Maxta designed, or when we designed the product from the ground up, we said data integrity is absolute, the minimum requirement. We have to make it really strong checksums. Actually, we go to the extent of being able to not only, when customers read a block, a lot of times if the data may be good, but the block itself may be wrong. You may read a wrong block, but if you just validate the checksum of the data within the block, it's correct, but you're reading the wrong block. A lot of storage platforms don't even catch it. Maxta catches even that. We not only catch inconsistencies within the block, within the data within a block, but also reading the wrong block itself. We provide availability when drive fails, when server fails, and even we have rack level availability and data center availability, making sure that data is extremely resilient. The second thing from an enterprise class features would be about short-term data protection, efficient snapshots, efficient clones. And the third is about capacity optimization. These days, every customer wants to do more with less. How can I get more capacity and not have to pay for everything, right? So Maxta software includes all capacity optimization features, very efficient snapshots and clones, and as we talked about, very strong data resiliency and availability. So there's no compromise in these enterprise class features when customers deploy their Maxta software.
Excellent, excellent. Well, some great questions. There's some remaining questions I know we can get back to after the event because we're running out of time and I want to respect everyone's time and their schedule. I appreciate everyone joining us today. Kiran, any final words to add?
Thanks everyone for attending the webinar. Feel free to send a note to sales@maxta.com. If you have any technical questions, please feel free to again send it to sales@maxta.com. We will definitely answer them for you. And for the remaining questions, we will answer them and send it out to the respective people.
Excellent. Well, thank you, Kiran, and thank you, Maxta, and thanks everyone for joining us. I hope you have a great day. Bye-bye.
Thank you.